Astronomy talk number 2. This one's going to be off the cuff as well. And it's pretty weird if you look at history as to how astronomers got to where they are today and the assumptions they hold to be true, which are just absolute nonsense. But they don't teach a lot of history of astronomy in school. Why we believe things, And I found out that one of the biggest reasons why they don't teach astronomy is because students these days they think that technology can answer all the problems that we have. They think that technology with the billion-dollar telescopes and the space age type stuff, they think that we're just going to solve all these problems by pouring billions and billions of dollars into this equipment, and with supercomputers and all this other stuff to do modeling of all these planetary orbits and stellar evolution cycles and things like that. They think by throwing money at things that they're gonna solve the problems. But it's strange because they have the attitude of, well, we need supercomputers to solve these problems, to do the modeling. No, you don't. You already have a supercomputer. It's right here. You need to use this. This is more powerful than any supercomputer in the entire world, still, to this day. So, by utilizing this supercomputer, what I did was find out one little secret, one little thing about astronomy that has enormous consequences. And well, let's go back to when people first started looking up at the stars, okay? They saw the stars as little pinpoints of light up in the sky, and there were other pinpoints of light that would move. And they're like, oh, what are those? Oh, they're obviously not stars. But they shine though. I mean, they have to be stars. Well, let's call them wandering stars. And wandering star was different from star. A wandering star was called a planet, which thus set in motion the false knowledge of thinking that planet was absolutely mutually exclusive of star. So what astronomers did is they kept this assumption. They rolled on through trying to explain everything. Galileo had his issues with, where's the sun at on all this? Are these wandering stars orbiting around the sun? Are they orbiting around the earth? And eventually we worked out the kinks with that. Figured out that all the wandering stars were orbiting the sun, which was the only star in our system, mind you. So we kept on trucking, kept on moving along, discovered, Neptune, Uranus, Pluto, all these other objects inside of our solar system. And throughout that time, I think in the 1700s, Laplace and a few others, I think Kant, they hypothesized that since all these objects supposedly were in a giant disk configuration, that somehow they formed like that. In other words, when the solar system was born, it formed from a big spinning disk of gas and dust, and little parts of that disk coalesced around a larger, bigger object called the sun. Now what that did was immediately, that even solidified further the idea that the wandering stars were mutually exclusive of big hot stars. It further solidified that assumption. So now we have people who use the language to differentiate the two when there was no evidence of it being true. And then you had these theorizers, these philosophers or astronomers or whatever, completely set that in stone by making the planet formation as a process that involves a disk. So here we are with a disk formed solar system, and astronomers they go out believing this disk, and they believe it for quite some time. And then the 1980s rolls around, and we start finding exoplanets, which are wandering stars around other stars outside of our solar system. So we find out that those exist, and now, 1980s, 1990s, 2000s, 2010s, it's 2015 right now, we find that somehow these objects are doing strange things. These exoplanets, they're orbiting too close to their host star. Gas giants are way too close. Rocky planets are really, really, really close together as they orbit the host star. I mean, their orbits almost touch each other. Some of the planets, they orbit, like, one of the planets would orbit this direction, another planet would orbit in this direction. So you have orbits which are completely off and don't fit the disk orientation model. And basically you have a huge mess of objects which completely defy the disk thing. So we're going, oh no. So we have to go all the way back to the 1700s when the disk thing was invented and find out, well, where did we go wrong? Well, the problem wasn't never with the disk. The problem was even further back, when we called the moving ones wandering stars and made them as planets, and we called the fixed one stars. What they didn't realize was that the wandering ones were just older stars. They should have called them older stars, not wandering ones. Because, well, let me put it like this. If you're an astronomer and you look up at the stars with your telescope, you see the bright ones, right? You're, oh yes, it's a star because it's bright, it's shining, it has a spectrum. Okay, fine, that's all good. But what an astronomer should have done is use their brain. They should have thought, they should have used their brain just a tiny, tiny bit. Be like, okay, well, what happens to a star? Just not even no education at all. Just a simple question. You can ask a kindergartner this, a third grader, or a high school student who has no background in astronomy. What would happen to something that's really hot, really big, and really bright as it dies? Well, if it's hot, it would cool down. If it's big, it would shrink. And if it's bright, it would dim. Now, when you're an astronomer and you look up at the stars at night, you call everything stars which are bright, right? Well, where are all the stars that are dim, that you can't see anymore, that don't have spectrums? Think about this for a second. What do astronomers call stars that don't shine? They call them planets. And that's where this discovery is so incredibly important. Because the stellar evolution models, which take stars as always shining and becoming red giants and exploding and becoming black holes and neutron stars and all this stuff, that's academia theorizing. They should have just used their brain. Said, hey, what happens to a campfire when you're out camping and it doesn't have more fuel added to it? Well, it dies. It cools, the fire dims, and eventually you just have the ash-covered embers, making it appear that the star doesn't shine anymore, that the fire is no longer hot. And that's what happens to all stars. They cool, they shrink, and they die. And they become what are called planets. And the reason why we had this huge problem was literally we gave labels to things which were never true without any evidence of them being true. We had no evidence at all that the sun wouldn't become a gaseous type object and become a lot smaller. We had no evidence that the gaseous type objects would cool and shrink and solidify into rocky type objects. Or at least we do have the evidence of it. We're standing on the evidence. But the reason why we have this problem now is because consensus science. We have everybody wanting to agree with everybody else. Stars are fusion reactors. Planets are formed in disks. The universe came from a giant explosion of nothing into something. Good luck explaining that one to any rational-minded person. And here we are, confused. How did the Earth form? Well, I'm going to explain it. Now, I don't have the birth of a star down completely, but I do know it has to absorb a lot of energy from the surroundings. So whatever gas cloud it forms from, it has to get really hot. There's a mechanism to get it really hot, and it expands like a giant balloon. Think of like a soap bubble. That's what the sun is. It's a giant soap bubble, basically, of plasma. And that big bubble, it collapses on itself. And as it cools and collapses on itself, its spectrum, its luminosity decreases significantly, its gravitational pull decreases significantly, it loses mass to solar wind and radiation and solar flares, and it shrinks and becomes a red dwarf. And over time, that red dwarf cools and shrinks and combines the elements as they cool into molecules, and then the first real stable molecules which can sustain higher temperatures are formed. And then those molecules combine with other molecules, and all that material differentiates itself into the interior of the star. Mind you, the most stable elements, they move to the center of the star first, such as iron and nickel, and the other elements just layer onto the center of the star as it cools, and it shrinks. And we see stars in different stages of this process inside of our own solar system. And we're even standing on one that's many billions of years old. The eventual fate of the sun is right below our feet. But hopefully this is a good short talk on astronomy number 2. If there are any questions, go ahead and post them to the page. If there's anybody that wants to ridicule or call me names or just be a nuisance, I'll just delete your comment. That's all I'm going to do, unless it's constructive. I don't really have time for that nonsense. But hopefully the mainstream astronomers and astrophysicists that are working can realize that the assumptions are what are getting in the way of them understanding nature. Alright. Oh yeah, today is February 17th, 2015.